Alright guys, welcome to day 2 of Pythagorean theorem with real life. Remember, the Pythagorean theorem is an equation used to find pieces of a right triangle. A and B are the legs, C is the hypotenuse. And this is my theorem. A squared plus B squared equals C squared. Alright, let's do an example. Brody is building a slide for his kids. The ladder is 5 feet tall and 13 feet long. What is the distance between the ladder and the bottom of the slide? The first thing I'm going to do is go ahead and draw this ladder as much as I can. The ladder is 5 feet tall, and this is our ladder to get up onto our slide. The ladder is 15 feet long, and the slide is 13 feet long. So again, this is our slide, and this is 13 feet long. What is the distance between the ladder and the bottom of the slide? So I'm trying to figure out what this component is. And so I know that since I don't know what that is, I can go ahead and give it a variable. Now, I'm going to go ahead and plug in and use the Pythagorean theorem. So I have a squared, since I don't know what that is, plus b squared, which is 5 squared, equals 13 squared. I don't know what a is, so I'm just going to bring that down. 5 times 5 is 25. And 13 times 13 is 169. Now, this becomes simple algebra. If I go ahead and subtract 25 from both sides, that cancels out. I'm left with a squared equals 144. If I take the square root, a equals 12. So the distance between the slide and the ladder is going to be 12 feet. Let's do another one. Alright, what is the length of the diagonal on a square with a side length of 5 units? Well, I'm going to go ahead and draw a square first. This is one of those problems where you have to think about what you know. I want to figure out what the diagonal is, or this thing that goes down the middle, cuts it in half. So since I want to figure that out, I'm going to go ahead and give that an x. A side length of 5 units. Okay, I can go ahead and label one of my sides, but I don't quite have enough information to use the Pythagorean theorem just yet. Okay? I know that squares have equal measures on all 4 sides. So if one of my side lengths is 5, the other one must also be 5. Now, this gives me enough information to use the Pythagorean theorem. I'm going to go ahead and plug in for our equation. A squared becomes 5 squared plus b squared, which is 5 squared, equals c squared. Now, 5 squared is 25 both ways. 25 plus 25 is 50 equals c squared. Now, the last thing I want to do is go ahead and take the square root. 50 is not a perfect square, so I'm going to have to estimate what it is. I'm going to pull 50 out and think about what are my perfect squares that are nearby. I know that 49 is a perfect square, and I know that 64 is a perfect square. 50 is closer to 49, and the square root of 49 is 7. The square root of 64 is 8. So that means that my choices are going to be 7.1, 7.2, 7.3, and 7.4. Since 50 is so close to 49, I'm going to choose to square 7.1. If I multiply those together, that's going to give me 50.41. That is pretty darn close to 50, so I can say the measure of this diagonal is about 7.1 units. Alright guys, that's going to be it for me today. Let's go ahead and practice.